Hey y'all, Dr. Kate Biberdorf here. Some of you might know me as a chemistry professor at the University of Texas at Austin, Hook 'em Horns, or as an author of 7 children's books and the nonfiction book It's Elemental, The Hidden Chemistry in Everything. But it's more likely that you know me by a different name.
Kate the Chemist.
Kate the Chemist.
Kate the Chemist. Sodium! This one's copper! And magnesium. Yeah!
Basically, I see chemistry and science everywhere and in everything. I've dedicated my life to demystifying science and using it to explain life's biggest questions. And that's what I plan to do on this podcast too. Each episode, I'll seek out a scientist, or 2 or 3, to help me answer those classic what-if questions that my college freshmen love to ask. Like, Dr. Biberdorf, could we build a high-tech science machine that can pull all of the carbon dioxide out of the air to slow down climate change? Or hey, Dr. B, what would happen if our entire planet suddenly became covered in water? This week, we're starting with the one I get the most often from my students and my mother. From the Stowers Institute for Medical Research and KCUR Studios in Kansas City, this is Seeking a Scientist, a podcast where science fiction meets reality.
I guess me and your grandma are going away.
How old are you?
7, but I look a lot older.
When we get where we're going, we'll never be sick, we won't get any older, and we won't ever die.
And on this episode, we're seeking a scientist to answer the question, could we slow down, stop, or even reverse aging? We're going to take a step back to look at aging in a way that you've probably never done before, with 2 of the top researchers working in this field.
We're the guys who are saying aging has a biology, and let's understand the science of this biology.
I also realized that aging was going to be truly reversible, that one day we are going to be able to choose when we die.
The genetic and environmental factors that actually affect your life expectancy, the difference between anti-aging and longevity, and advice on what you can do to improve your health and possibly extend your life. After all, aging is a thing all of us think about.
It's very hard to consciously fathom how old you are. I mean, even though I can say that number, inside, it doesn't compute.
More people that I know are dying.
I don't really fear getting older.
It's fun to be a kid.
Not fulfilling what your purpose is, I definitely think that's pretty scary.
I feel it in my knees. I feel it in my back and my shoulder.
Aging can feel like something that's out of our control. But is that still the case?
I'm so hyper aware of the passage of time.
Should we really live to 200?
Yeah, where does it stop?
I do often have that Jurassic Park thought of we can, but should we?
Before we go too deep, I've invited the Robin to my Batman, the Crick to my Watson, Dr. Alejandro Sanchez Alvarado. In addition to being the executive director at the Stowers Institute for Medical Research, he's a molecular biologist with a knack for explaining complicated biological processes. So, Alejandro, what even is aging?
Yeah, so passage of time. You can see aging right before your eyes. It's not something that's invisible. You can see aging by looking at sunrise and the sunset. That passage of time is what eventually will be interpreted by us as age.
Alejandro spends a lot of time in the lab looking at how a range of species like flatworms, salamanders, and even plants age. He explores what's possible with their biology and tries to figure out how plants like the Azorella compacta can live to be 3,000 years old.
Every organism has its own clock of how long they're going to be alive. And yet, whether you're a goldfish or you're a cat or you're a human being made out of primarily the same material, why is it that their lifespans are so different? Shouldn't everything last the same?
I see this every day when I look at the aging faces of my 13-year-old dogs, Betty and Dort, short for Dorothy. Why can't they live to be 100? Well, according to one study, the human body has ways of lengthening our lifespan by slowing down our DNA mutations. So even though dogs and humans go through similar aging processes, dogs experience aging much faster. So a dog's body starts to show signs of aging in just 8 weeks, but those same changes take 9 months to happen in humans. And we can see this all across the animal kingdom. Larger species typically live longer lives than smaller species. And another thing you should know is that regardless of species, our chronological age does not match our biological age. The number of times our body has orbited around the sun has nothing to do with what's going on inside of our bodies. Throughout our entire lifetime, our cells are continuously regenerating and then dying.
So it turns out that on a daily basis, we actually shed, naturally and normally, anywhere between 40 to 70 billion cells per day. And that's a huge amount of cells, right? So in a year, you are essentially shedding your body weight. And yet, we were able to recognize our faces in the mirror this morning as we were brushing our teeth, combing our hair. And so this whole process of us thinking that we really are not changing that much, that we have this stable appearance that we, display to the rest of the world is belied by constant change.
Is it true that the average cell in the adult is about 7 to 10 years old? So even though I'm 36, the oldest cell in my body is actually an elementary student?
Yeah, in fact, as we speak right now, probably a cell is born as we are having a conversation. People ask me, how old are you? I say, well, it depends. So, astronomically, I'm 58 years old. But biologically, I am a mix of ages because I have cells that were born just now, cells that were born last night, cells that were born several years ago, and cells that were born even 58 years ago. So it really is a melange. It's an amalgamation of ages.
This cell turnover is crucial for maintaining daily organ function. When our bodies go through normal deterioration, we use these new cells to repair any issues that pop up in a process called tissue homeostasis.
It tries to keep stability on the face of constant change, of constant turnover. And so there's a lot of birth and there's a lot of death ongoing all the time. And so homeostasis is when both of those poles are in balance.
Would it be fair to say that tissue homeostasis is what helps kind of with our organ long-term life? Like it helps the normal wear and tear, the physiological wear and tear of organs?
Yeah, that's correct. A perfect example of tissue homeostasis is your skin. It's a really perfect example because, you will get sunburned. And even if you don't get sunburned, the most external layer of your skin is constantly flaking off, right? So in order to keep the skin alive, which is an organ, you really need to have that homeostasis going. Otherwise, you will have injuries that you cannot repair.
So when stem cells divide, their daughter cells can either amplify, make more of themselves, or they can go into our tissues to help repair organs so that we can stay alive. But what's key here is that the cell birth to death ratio decides the age of our biological clock. If we make too many cells and don't kill enough cells, our body starts to grow tumors. If we kill too many cells and don't generate enough new cells, our body starts to show signs of aging. And like with Goldilocks and the Three Bears, when you have the proper birth to death ratio, it's just right and your body can fix minor organ injuries.
That capacity to repair of our bodies is really, really extraordinary. So we are not really seeing like a head's growing back or limbs growing back, but it is a constant state of both tissue homeostasis and repair and regeneration. So we are not that shabby.
Not that shabby. But how does your body know how to do all of this? It has to do with your DNA. When I picture DNA, I think of a long twisting ladder that seems to never end. Now, chemically speaking, DNA is a very large polymer made from 2 chains that wrap around each other to form a double helix. DNA is extremely important because it contains the genetic information for your body, kind of like a blueprint to your house. All right, now this brings me to genes. So genes are smaller segments of your DNA, and genes are hereditary. They're made up of chains of amino acids that allow your organs to act like themselves. And then there's this third important element, the epigenome, and it controls the DNA and tells your liver to act like a liver and your brain to act like a brain. Your epigenome is basically your body's software, and it is not inherited genetically, unlike genes. So, if the epigenome is the software, then your genes are the code, and the code is stored within the DNA. All three pieces are needed in order for your body to repair typical organ damage without contributing to aging. Are you still with me? Good. Now I want you to meet a person who you could say defied a lot of expectations. Jeanne Calment, born in France in 1875. What you're hearing is an album she recorded in her later years, and she had a lot of later years. Jeanne Calment lived to be 122 years and 164 days old, making her the oldest human whose age has ever been verified.
Ladies and gentlemen, she comes from the 19th century. For the first time, you're going to listen to the voice of Mrs. Jeanne Calment.
Bonjour, je m'appelle Jeanne Calment.
In her very full life, she met Van Gogh, who she described as kind of rude, saw the Eiffel Tower being built, and lived through too many wars. Plus the inventions of the light bulb, automobile, television, the computer. She was a wife, mother, and towards the end of her life, when it became known that she was as old as she became a pretty big celebrity. She was highly celebrated and, of course, researched.
Bonjour Madame Calment, je m'appelle Jo, la petite fille dans l'histoire.
Vous vous appelez Jo.
Jo,
no matter.
Isn't it amazing that she might have seen Vincent painting here in these fields around Arles?
Through the majority of her very long life, Jeanne Calment was in great health, except in those very final years when she essentially became immobile, confined to a bed, virtually blind, and almost incapable of speech. She died in 1997.
For 122, she lived most of her life, she had fun, okay? And those are decades and decades of fun. So that was an inspiring story. But for me, it was more of how to turn it into science, right? And how to form an hypothesis and support an hypothesis that those guys have actually genes that slow their aging.
That's Dr. Nir Barzilai, the director of the Institute of Aging Research at Albert Einstein's College of Medicine and the author of the book Age Later, Health Span, Lifespan, and the New Science of Longevity. He spends a lot of time researching centenarians. Now, centenarians are people who live to be at least 100 years old. His Longevity Genes Project has studied the genetics of over 750 families of centenarians and their children. Specifically, he wants to know how they live so much longer than their peers. He's part of a brand new field, commonly referred to as aging science or longevity science, that has blown the roof off what we know about the biological limits of the human lifespan.
I'm a geroscientist. I'm one of the founder of this movement.
So for our listeners, could you give maybe a one-sentence definition of what geroscience is?
Geroscience is really understanding the biology of aging in order to understand what are the targets that we can have, the treatment targets that we can have that will change this landscape of aging.
And to be clear, geroscience is very different from anti-aging, which brings to mind Botox and dietary supplements.
Anti-aging are people who says, hey, we can stop your aging, okay? We will give you something, and, some of it might be good, some of it might be bad. It's usually good for the economy, to invest, but it's not science-based.
Now, dietary supplements can be found at any drugstore, sold without proof of efficacy or even safety. Unlike pharmaceuticals, which undergo extensive testing before being released to the public. Some dietary supplements contain chemicals or compounds that are similar to those in pharmaceuticals, but they have really drastic side effects or contaminants. Like in a recent study, it was reported that 1/3 of the products analyzed contained a known kidney toxin. So, why am I telling you this? To make sure it's perfectly clear that the scientists I'm talking to are hardcore scientists that have dedicated their lives to learning exactly how to combat aging on a cellular level. They are not selling snake oil on the street corner. They are looking at aging as a microscopic biological process that might be reversible. In the past century alone, humans have nearly doubled their lifespan, but with that, we've seen an increase in age-related diseases. The big four are diabetes, cancer, heart disease, and Alzheimer's.
Okay, so look, human lifespan throughout evolution, let's say there's 100,000 years of human evolution, life expectancy was between 20 and 30, okay? There are very few people, there are old people all the time, but not a lot of them. And something happened in the last 150 years where our life expectancy jumped by threefold, okay? It's like 8 in most of the world, declining in the United States. It's 76 in the United States now, but, and this was by harnessing the agriculture, cleaning the water, sewers, vaccination, right? A lot of prevention. And those diseases that you just mentioned have not been during human evolution. They're really, really very new. Most people didn't die from Alzheimer's or diabetes or cancers. But we know something very important about these diseases. What drives them is this aging. It's this biology of aging is what drives them. So we're saying, let's intervene in the biology of aging and prevent all those diseases.
Near learned that by targeting the so-called hallmarks of aging, you can increase both the lifespan and the health span of animals. Lifespan is how long you live, whereas health span is how long you stay healthy. There are 12 common hallmarks of aging, or more technically, 12 biochemical changes that eventually lead to death. Scientists typically agree on the first 9, but we argue about the last 3. You're probably familiar with the ones like inflammation and metabolic dysregulation, but stem cell dysfunction, epigenetic changes, and mitochondrial quality control also can contribute to aging. In simple terms, scientists now know that when something goes wrong with one of these hallmarks of aging, we can sometimes fix it and live longer, healthier lives. But if you ask centenarians, they have their own, sometimes surprising theories for why they think they've lived such long lives.
Everybody had their explanation that absolutely made no sense, okay? I eat fat, chicken fat all the time, right? Or I eat chocolate cake all the time.
Other theories include helping those in need, a positive attitude, and sheer luck. But on top of those less substantiated ideas, even the centenarians recognized that their long lives were also connected to good genes. Near learned that centenarians and their offspring often have longevity genes that protect them against age-related diseases. For non-centenarians, at age 80, only 10% are disease-free. But for centenarians, at age 100, 30% are disease-free. Obviously, Near wanted to know how they were pulling this off. So he did what every good scientist would do. He analyzed the genome of 44 centenarians in search for the perfect genome.
What we've discovered is that there are several ways to get to age 100. There are several genes that can get there.
But to his surprise, each centenarian had at least 1, if not 6 genes that should have made them sick. 2 of them even had the gene linked to Alzheimer's, which, statistically speaking, should have resulted in dementia at 70 and death at 80. But here they were, still alive and kicking at 100 years old. What he found was that these centenarians had a special set of longevity genes that protected them from mutations in their DNA, mutations that should have killed them. There are also environmental discrepancies to consider: healthcare, equity, resources. According to Near, in the United States, people living in poverty live 20 to 30 years less than rich people. But for him, the field of geroscience is all about equity and working to promote enhanced health for everybody, not just the elderly. We can't forget diseases like cancer and diabetes can affect young kids too. Near's ultimate goal is to increase the health span while decreasing the period of morbidity for every human on Earth.
People who survive cancer, they age rapidly, and we give them radiation and chemotherapy, right? They get the age-related disease at a young age. HIV People with HIV have diseases 10 years before their cohort. The poor, the disabled, they all need help. And if your chemistry guys actually are interested in going to Mars, we're not going to Mars before we stop aging, okay? We are not going to get there without diseases, and we're never going to come back. So there's a lot of reason why we need to target age.
If you could slow down aging, would you?
If I can slow down, would I? Yes, I would. I feel like sometimes life goes too fast. You know, we need a little bit more time.
The world is literally so scary, and I kind of think 100 years max is probably as much as I got in me.
You know, I want to live as long as I possibly can without being a burden to somebody else.
I don't think our society is set up to have people live that long.
I think it would kill like the urgency that I have for life.
I think I'm kind of scared of like wasting my time.
In his book, Dr. Nir Barzilai states that our best shot at living a nice, long, healthy life includes 4 things. 1, diet, specifically intermittent fasting. 2, exercise, do something active every day. 3, the more sleep, the better, it's connected to dementia. And 4, social activity. Were you surprised about that last one? Because I was. So I asked Dr. David Sinclair, a genetics professor at Harvard and author of the book Lifespan, Why We Age and Why We Don't Have to, if he agrees with this list.
Social activity is really important. A big study out of Harvard for over 50 years showed that people who have a reliable partner are the ones that live the longest, even cutting out every other aspect of health and lifestyle. So yeah, if you're lonely at home, get a pet. If you can go outside, get some friends, it's really, really important. And not friends that stress you out, friends that you can really call and cry on the shoulder of. Those are the important ones. They're really rare. If you've got a friend like that, really work hard to keep them and do them, be a good friend to them as well. I would add that eating colorful plants, I've gone vegan, I've dropped alcohol, I barely eat sugar ever. And occasionally I'll have a drink, but not much. Eat less often. Don't starve. We are told to eat 3 meals a day plus snacks. Don't ever be hungry. That does not agree with the science. The animals and the people that live the longest on the planet are those that don't constantly eat.
Also, don't be afraid to go outside and take a walk in the snow. Believe it or not, David says cold air keeps that biological age down. And there's one more thing worth mentioning. If you can, Nir suggests marrying a person with longevity genes. Just being near a centenarian seems to correlate with a longer than average lifespan. So Nir and David say it's been very difficult to get society interested enough over the years to fund the research necessary to learn more about geroscience. And that led David to do some kind of wacky, creative things to get people's attention. I heard you travel with an age suit. I mean, is that true? What does that look like and what do you do with it?
Oh boy. Well, so the age suit weighs about 100 pounds. So I don't always travel with it, but I have shipped it around to demonstrate to people what it's like to feel 80. And you strap weights on your legs, your elbows, your arms. You put on these ear protectors, earplugs. You put a face mask on so you get blurry vision. And what it shows you is that it's pretty hard to be a typical 80-year-old. You feel heavy, you feel tired, you can't see well, you can't hear well. And most people who are young who put this suit on, it's the first time they understand what it's truly like to feel old.
The age suit is a beautiful way to connect the macro world with the micro world because time and age can be a hard thing to translate. I mean, he's trying to help people actually feel age, feel its burdens, and to encourage people to investigate what's going on at the molecular level. And all of that work has been paying off. Now, let's rewind the chronological clock to 2018 and hear the story of the biggest eureka moment in Dr. David Sinclair's professional life. Let me set the scene. David wanted to find out whether it was possible to turn back the biological clock of a mouse. So he asked his graduate student to run a highly unconventional experiment. They took the mouse's optic nerve, which is the nerve that sends the signals between the eye and the brain, and they crushed it, blinding the mouse. Then they injected 3 genes, specifically 3 Yamanaka genes, into the crushed nerve. After 3 weeks, they realized that they had achieved something thought to be impossible. The crushed optic nerve was regrowing back to the brain, restoring the mouse's sight. You see, old crushed nerves do not grow back. They cannot repair themselves, but new youthful nerves do. So not only did they have the first recorded result of repairing an old optic nerve, but they also realized that their nerve was now half the age than when they originally started the experiment. David used science to make the mouse's optic nerve young again.
And the cells went back in time by about 75%, but no more than that. And they don't form cancer. We just got a young mouse.
It was this experiment that prompted David to have an even more profound realization.
It's always also fun as a scientist to know something with your team that no one else knows, like you've discovered the secret to something. The exciting thing about that was that I also realized that aging was going to be truly reversible, that one day we are going to be able to choose when we die.
So this result led David to create a whole new theory. It's called the information theory of aging. Basically, we age because our cells forget the original intentionality that's encoded in the epigenome.
If you think of the DNA and the proteins in the cell as the machinery, like a computer, then the epigenome is best described as the software. And what I'm saying is it's not the machinery that, even though it gets damaged over time, that's not the real reason that the computer doesn't work anymore. It's because the software gets corrupted and it doesn't know how to function. And the good news is that if our theory is correct, we may be able to find a backup copy of the original software and just do a reboot of the body and make it run like it was young again.
To test this theory, David studied 2 genetically identical geriatric mice. One was given a special booster shot that's believed to protect and repair our epigenome and DNA, and the other was not. And then the mice battled it out on the treadmill. Naturally, the mouse with the booster completely outsprinted its twin. David remembers how one of his postdocs came up to him and exclaimed, "David, we've got a problem! The mice! They won't stop running!" I'm going to share a video of this on our social pages because you've got to see it for yourself. This result, besides being absolutely adorable, showed once again that David's theory about being able to reset the epigenome might be correct.
Often people say, why would I want to live longer if I'm just going to get dementia? So it's really important that any technology that we come up with that slows and reverses aging includes the brain. So after we've rejuvenated the eye and cured blindness, the next goal would be to try to cure hearing and then the entire brain, treat Alzheimer's disease.
Y'all, prepare yourself for this next part. In order to study the brain, David grew teeny tiny human brains. They have thoughts, they might dream, and David has found a way to reset their ages.
Pinky, are you pondering what I'm pondering?
Tried to make you immortal.
You tried to make me a killer!
He gave him infinite power, eternal life.
He's also studying these things called senescent cells, aka zombie cells, which stop multiplying, and as their name implies, they don't die. They just kind of get in the way.
They're coming to get you, Barbara.
Are you okay?
And these senescent cells are bad because they pump out inflammatory molecules that make your immune system overreact, and they can also cause cancer as well.
Basically, they release molecules that can trigger unwanted chemical reactions, like how a moldy piece of fruit can ruin the entire fruit bowl.
It could become cancerous and kill us, or it could shut itself down and become a zombie and just sit there, like an angry little cell. And so what we're learning is to prevent them from becoming zombies or kill them in the body and get rid of them, which is not great if these are essential cells like a nerve cell in the brain. And what we're doing in my lab that's unique is to reverse their senescence. So to get the zombies to be cured so they can be normal again and grow again.
That's just fascinating. It reminds me of the first thing I saw when I opened your book, Lifespan. Your dedication is to your great-great-grandchildren. I mean, that's a way to grab people. Do you really believe you're going to meet your great-great-grandchild?
Well, I believe it's possible now. Let's put it this way. We now know how to slow aging. You know, I've been doing this for a while, and I'm at least a decade younger than my birthday candles would tell you. I think I have 2 gray hairs. I'm 54 almost. I'm slowing aging pretty well. That won't get me to 200, of course. The reprogramming work with these Yamanaka factors, that's a totally different ballgame. We've discovered that there's backup software that can be rebooted in our bodies, in every cell, and it's safe. And you might say, well, that's for our kids or our grandkids to reap the benefits of. And I don't think so. Since that eye experiment, we started a company immediately. We've raised over $100 million.
According to David, the first person to reach 150 years old has already been born. His company, Tally Health, uses a cheek swab to test your DNA for your biological age. And what are they looking for? It's chemistry! As you age, methyl groups attach to your DNA, and we can count the number of methyl groups to determine your biological age. So for my non-chemists, methyl groups are just a small collection of atoms containing 1 carbon and 3 hydrogens. And Tally Health uses these methyl groups to make an age prediction. Now, once you have this number, the group makes specific recommendations to optimize your health span and your lifespan. Because the truth is, right now, aging research is in a similar place as cancer research was back in the 60s. But what's exciting about that is that there are a handful of promising pharmaceutical drugs currently being developed. In general, everybody wants the quick answer to living a long, healthy life and the secret to slowing down aging. But honestly, the truth is a combination of factors and approaches. From an evolutionary standpoint, we were not meant to live forever. But our human nature pushes us to wonder and test the limits of our boundaries. After all, the biggest question, what even is life, has been plaguing philosophers and scientists for millennia. Today, David has his own unique take on it.
But yeah, the way I look at life is that it is a survival machine that responds to its environment to live as long as possible to ensure the survival and reproduction of the species. And not longer than that. And that's why we age, because we do live as long as we need to procreate and ensure the survival of our kids. But we don't need to be around for 300 years. We've replaced ourselves within about 50 years. And that's why we start to fall apart after that. But that doesn't mean we can't. There's no law of biology that says we have to age at 50 and start to decline. There are many species that live longer. Whales can live 200, 300 years. And they're very close cousins. So I think it's just like we've engineered everything else around our world. This is the same progression in humanity, is to look at what causes us pain and illness, which is mostly aging brings about diseases, and address what's staring us in the face as one of our biggest problems, and tackle it with all the technology and know-how that we have. Because when we do, and people live healthy lives until they're 100, they'll look back at today when we didn't even look at aging as a problem and think, what were they thinking? Why didn't they even address that?
Then again, aging isn't all bad, is it?
Actually really excited to have gray hair. I think it'll look really, really good.
As I get more opportunities to actually be able to do stuff, I can actually help other people and help the world.
Well, I'm still going. And I'll keep on going until I can't anymore.
Just thinking about where I could be in my career and starting a family and everything, when a mini me running around, that excites me.
The excitement of having a budget and having a certain amount of money to spend on each thing, buying all your favorite foods, not having to eat the vegetables you don't like.
I can drive.
Seeing my family grow up and be successful or struggle or
That's exciting.
I'm hoping that as I get older, I can become like more sure of myself and sure of my decisions.
It's a beautiful thing. Getting older, you get wiser. You get more beautiful in the inside. You learn more.
I do think that there's an inherent beauty to the way in which biology adapts itself to time.
For me, aging is just science and chemistry in motion. We can't physically see the cells turning over or regenerating, but we can see the wrinkles on our face and feel the pain in our knees. Will we one day be able to have the best of both worlds? The memories and maturity of a 122-year-old Jean Calment, but the body and the eyesight of a college freshman? In that world, we might finally be able to see a fair matchup between LeBron James and Michael Jordan, or Serena Williams and Billie Jean King. Or like David predicted, we could actually have quality interactions with our great-great-grandchildren. Thanks for listening to our pioneer episode of Seeking a Scientist. If you liked it, please write a review or share it with a friend. It'll help us celebrate these badass scientists and get them that standing ovation they so deserve. Seeking a Scientist is a production of KCUR Studios in Kansas City, made possible with support from the Stowers Institute for Medical Research and design help from PRX. It's hosted by me, Dr. Kate Biberdorf, aka Kate the Chemist. You can follow me on Instagram and TikTok at Kate the Chemist or on Twitter at K8 the Chemist. This episode was produced by me, Suzanne Hogan, and Byron Love. Mackenzie Martin is our editor, Gabe Rosenberg is our digital editor, and special thanks to Genevieve Des Marteau and the Stowers Institute. Our original theme music is by Coma Calling, and you heard music from Blue Dot Sessions and Jean Calment. Also, clips from Cocoon, The Curious Case of Benjamin Button, Vincent and Me, Mary Martin's Peter Pan, Pinky and the Brain, The Lost Boys, Interview with the Vampire, Night of the Living Dead, and 28 Days Later. You also heard voices from students and staff at the University of Texas at Austin, KCUR staff, and some kids from Austin, Texas. Next episode, we're jumping into the ocean, so grab your snorkel and fins and magnifying glass because we're going to be looking at something tiny that is changing the entire ecosystem in the Pacific Ocean.
You want to see the most beautiful thing I've ever filmed?
Until then, if you want to see a crazy behind-the-scenes video of me using an app to see what I'm going to look like when I'm older, check out our Instagram at Seeking a Scientist or Twitter at Seeking a SciPod. You can also subscribe to our email list at seekingascientist.org. Okay, one last question. If you could share one piece of advice for our future scientists, what would it be?
Have faith in yourself and never take no for an answer. And then when you do make a discovery or make your mark or do something important and you get criticized for that, believe in yourself.
Read with abandon. If you find something that catches your eye, read it. That is the best way to come up with an appreciation of ideas when others may have seen it but did not appreciate the idea.
And then don't be afraid to ask questions.
And don't be afraid to ask questions. That's absolutely right.
I agree with that. I tell my students that all the time. If you have the question, that means you're a scientist. That's all it means.
Exactly.